Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a very special guest. His name is Matt Kappers, and he is CEO of the Coretec Group. It's pretty exciting stuff. We're going to talk about anodes. That's right, anodes. That's what makes your batteries work, and he's going to tell you how to make your car go 10 times as far. I wonder when we're going to have the first electric vehicle go all the way around the world. That'll be pretty cool. And so we are going to let Matt introduce himself now.
Great. Thank you, Sean. I appreciate the opportunity to be with you and your audience. I'm Matt Kappers. I'm the CEO of the Coretec Group. We have a pretty special group of people here who have a specific expertise in engineering silicon. And we're using our expertise to develop an anode with a high level of silicon in it that will dramatically improve performance of lithium-ion batteries. I'm really proud of our group here. And as we get a little further along, I can tell you a little bit more about our battery program, which is called Endurion.
So that's pretty interesting. I think it's probably a good idea to start educating our listeners here about what's up with a silicon anode. And so most of the time with our lithium ion batteries, and we don't really talk too much about lithium batteries. And so if we had a lithium anode, we would call that a lithium battery. And those aren't too good for recharging at this point in history. But there's something about silicon that makes it a better anode. And so your cathode is all that stuff that we're talking about when we talk about LFP, lithium iron phosphate, NCA, lithium nickel cobalt aluminum oxide. And then there's the NMC, which is very popular, lithium nickel manganese cobalt oxide. I think I had that right. Does that sound good, Matt?
Yeah, I'm impressed, Sean. That's great.
Yeah, and so we're not going to be talking as much, I don't think, about the cathode part of the chemistry. We're going to be talking about the anode, which is what makes your company special. And so the anode typically in most of these batteries are graphite.
That's correct. Yes.
And yeah, and that's carbon. And I believe that there's some of these companies that are using a combination of silicon and graphite. Does that sound right?
You are correct. And Sean, I think it's worthwhile just to take a step back. Your typical battery has a cathode, an anode, a separator, and electrolyte. And with our Endurion program, we're developing the anode part of the entire battery. So what we're developing with the anode could potentially be used with other types of batteries and other types of electrolyte, for example, a solid state or a semi-solid state.
Yeah, so that's pretty neat. So are you talking about having 100% silicon anode, or how does that work?
A little background, Sean. Silicon has the ability to hold 10 times the amount of lithium ions as compared to your typical graphite anode. Now, one of the fundamental problems with silicon, silica, is it's fragile. And as it expands and contracts, it fractures. I always use the example, we're old enough to remember the chocolate dip cones. You get the vanilla ice cream, they dip it in the chocolate and it gets that hard shell around it. Well,
We should go
think
get
about
some right
think
now. Yeah.
Yeah, exactly. So think about if that ice cream would expand 300 to 400 times, that chocolate shell would just break up and it would end up falling apart. Well, that debris gets in the electrolyte, which makes it hard for the ions to get through and pass back and forth. So our solution is to kind of embrace that chocolate covering, and we're developing a polymer that has the ability to kind of expand and contract a little bit without the fracturing piece of it.
So how does that work? So you say a polymer and then you have the silicon and you're trying to make it so the silicon doesn't crack like the chocolate?
Well, it isn't that the silicon cracks. It's the layer that's called the solid electrolyte interface layer, the SEI layer. There's when the chemical reaction happens between the ions in the anode and the cathode, it develops a layer around the silicon. And that's the layer that we're purposely engineering so that it performs better. And then the second piece of this, Sean, is we're using nanoparticles, very small particles of silicon. Some of the other silicon battery anodes out there are using what they call bulk milled silicon, where they just get a bigger piece and they grind it down. We're using a bottom up approach where our silicon is made through chemistry and it can be as small as 10 nanometers. So the smaller the silicon, the less likely it is to expand and contract as much and have that bad effect. So our approach is twofold. One, we engineer the SEI layer around the silicon, and two, we use very small particles of silicon. Does that make sense?
Yeah, somewhat, but I'm sure it's still pretty complicated. So you have some kind of polymer that holds the little small tiny pieces of silicon, and then those little tiny pieces of silicon hold the lithium ions. Hmm.
Correct. Exactly. You mentioned 100%. Our goal is to get an anode with 20% silicon. And that alone, kind of the mathematics on that, would double the capacity of a lithium ion battery, which would be a tremendous improvement. The idea of a 100% silicon anode is a very difficult thing to achieve, but incrementally, just a 15-20% increase in silicon in the anode will have a very dramatic effect on the performance.
So does the silicon anode still have graphite in it?
Oh, yes, exactly. We're putting our silicon in a graphite support. So, yes, it's part silicon, part graphite.
So what would you say maybe the comparison would be to what your average electric vehicle has right now as far as percentage silicon and to what you're working on?
Right now, most EV batteries do not have any silicon in it. So, this is a significant breakthrough in the technology.
Okay, but I guess some EVs do though, right?
Right.
So,
Yes. Yeah.
and so
Yeah.
what percentage increase is yours over what they're using?
Probably double.
Hmm.
A lot of this is a pretty tight-lipped community. It's still new and different. We just filed some provisional patent in May that gives us some protection, but it is a little bit of an arms race trying to get to the best silicon anode.
We'll have to go dissect some of those cars to see what they have and take them apart.
Exactly. Put them up on a rack. Yeah.
Uh-huh, yeah. And so the idea for you is you come up with this technology, and then are you going to be working with battery manufacturers or manufacturing yourself?
Exactly. Our anode would be air quote drop-in solution. So we could drop this into other lithium ion cathode electrolytes applications. At this point, we don't intend on manufacturing batteries ourselves. So we would partner with a battery manufacturer or an automaker or a tier one auto supplier to use our application.
Great. And so do you deal with patents and all that kind of stuff?
Absolutely. Yeah.
So,
But we could be in a position where we're going to license Endurion. That's probably the likely way to go.
great. Can you tell us all your secrets?
No, I can't, Sean, but that was a good try.
Oh, darn. I thought I'd catch you off guard or something.
Yeah. Yeah.
No, I mean, all this is pretty neat. So silicon is 10 times better than graphite approximately at holding
Oh, yeah.
lithium
Yes.
ions. And
Yes, exactly. But to achieve that 10x is a very lofty goal. And as I said, if we can just double the amount of silicon, it should double the energy density.
it sort of sounds to me a little bit like even with heat making something contract and relax is what maybe a different analogy too, sort of like the chocolate on your dipped ice cream cone. And another thing too, I just wanted to mention to people out there too, just some battery stuff, is that it's silicon, just like with solar cells and computer chips. It's not silicone. Silicone has oxygen in it. It's more like a gasket or something. And another thing I like to point out too when we're talking about batteries is we talk about specific energy, and that's energy per weight. And then there's energy density. Density means per volume. And with batteries, a lot of times they say energy density when they mean specific energy. So I always want to point that out to people.
Right. And Sean, one thing as our development continues to make progress, some of the data that we pull out of this, there will be other applications, not just for electric vehicles, for our Endurion program. As you know, there are many different ways a battery could be used, everything from stationary grid power to eVTOL, whether it's unmanned drones, to your consumer electronics, to all sorts of military applications. So, in many respects, we're going to see where our data takes us on our development.
Yeah, I imagine with increases in lithium ion battery technology, it could be everything from my watch battery to the world's largest energy storage system. That would be
Exactly.
all the different applications. So pretty groundbreaking. And I kind of think of it too as if you look at solar cells, we're pretty mature as far as growing that technology, and we're doing pretty good. And with batteries, there's just so many different combinations of elements on the periodic table and different ways to put them together that I think that the growth and that we can have, how good they are, so we're talking specific energy, energy per weight, has a lot of growing to do. And you're part of that growing, so that's great. So if we look at all the different types of applications, it's pretty interesting how you can look at the smallest battery, which for me is my watch battery that's rechargeable. I have a rechargeable watch battery. If you looked at the other types of watch batteries that are not rechargeable, those are the ones that would be the lithium anode battery, and instead of a lithium ion battery where the ions go back and forth. And that battery actually can hold twice as much energy per weight or per volume, pretty much. And if we look at the lithium ion battery, which is nice because it's rechargeable, we can see that your technology and all the different kind of technologies that are developed can be used to make it better for my watch, all the way up to the world's largest energy storage system. And right now, the world's largest energy storage system is not too far from me in California. It is about 3 gigawatt hours. So I was wondering where you are located.
We're very fortunate. We're headquartered in Ann Arbor, Michigan. It gives us great access to University of Michigan. There's the battery lab at the University of Michigan, which is supported by Ford Motor Company, has some great resources for us. And then in addition to that, obviously we're close to Detroit. And then we also use some of the equipment at Wayne State University.
Oh,
So
great.
these are $1 million pieces of equipment. So it gives us great access to our work.
Yeah, I do a lot of my work for HeatSpring. We do the online solar training where it's on demand. It's the best thing in the world. People should check it out. And the headquarters of HeatSpring is in Ann Arbor, Michigan. So next time I go there, I'll
It's
look you up.
Please, please. It's a very vibrant community, just being next to the university. But as a result of that, there's all sorts of some really neat developments here that we get to share with. But, Sean, back to your applications, it's really fun to be part of the battery community because things are going at light speed. These developments, not just with the silicon anode, but just in general, like you mentioned, the LFP, the solid state, the semi solid state, all that, it's really interesting. And I think we're going to see some significant developments within the next 4 or 5 years across the board.
And so are you working with the primarily just the silicon anode, or are you working with other stuff too?
Just the anode, yes.
Okay. And does it make a difference to you what kind of cathode it is?
Oh, very much so, Sean. Part of our challenge is to kind of eliminate the different variables so that our work is specific to the anode. So, for example, there's Gen 1, Gen 2 electrolyte, there's additives that go into the electrolyte, there's different cathodes. So what we're trying to do is eliminate all those variables so that when we put batteries on test, we're really just testing the anode. So yeah, that's one of our challenges is just there are, 6 or 7 different aspects of a battery that could be different, which would affect the performance. So we're eliminating those. So we're concentrating just on the anode.
And so when you say you do that, like let's say you're doing some research, are you doing research with the LFP type of battery, the NMC, the NCA?
What we're typically doing is just using the typical lithium ion battery. We don't want to get anything too fancy. We've been approached and we're talking with some partners who have solid state ideas and concepts, and we're using just the off the shelf kind of components.
Because I know that in the energy storage industry right now, there's kind of a big movement towards using LFP because there's no cobalt in it. And there's all the controversy with cobalt and half of it being in the Congo, most of it being mined in the Congo, and they're having problems with unethical labor over there. So I guess yours is pretty much agnostic to which type of cathode. And we're starting to see actually even more cars that are using the LFP too. I know that a lot of people in the earlier days of electric vehicles were getting this terrible range anxiety where they were just worried that they were going to go on some super long vacation every day and not be able to go far enough, which really, when you have an electric vehicle, it's not that big of a deal because you're not going on a big vacation every day. I find myself always having my electric vehicle battery probably like 90% of the days, I'm between 60 and 80%.
How far do you drive typically, Sean?
Yeah, I mean, I don't have a big commute or anything like that. So I just drive around town, probably half hour driving or something on an average day or less than that, 20 minutes, something like that. I know it would be different for people with a big commute, but still, even with a commute, you would drop it down further. But it's great. Another thing too about increasing the specific energy for your battery is you keep it more in that range where it's good for the battery. So if you have a bigger battery, you can keep it between say 80 and 60%, which is pretty optimal for most batteries. Whereas if you had a battery that was half that size, then you would be going, say, down 80, down to 40%. And that would be not
Right.
as good for your battery to bring it down as far.
It's interesting, Sean, we talk about all the developments and how there's a push to increase range and everything. You got the government that's putting a lot of money behind battery development. You have the automotive industry that's putting a big push behind it. And then you just have the general market conditions, where, like you said, range anxiety, that's pushing development. So we talk about how in the next 4 to 5 years, we're going to see some significant developments. And that's part of the reason why is there's so much support for new battery development.
So with your technology getting doubling the amount of range that you could get out of a battery pretty much, when do you see that happening on a regular basis? Like, is
Well,
it like 5 years, 10 years?
oh, no, it will be sooner than that. We have a very specific technology roadmap, how our development's going, and I will tell you that we're on track. But, Sean, we're a publicly traded company, so I really can't get into a lot of forward-looking statements. So
How do we find your company so I could go stick my billion there?
the ticker symbol is CRTG.
CRTG. Great.
Yes, sir. Yeah. So I have to be kind of careful when we talk about forward-looking statements, but I can say that our technology roadmap is right on schedule and we're doing everything that we're doing. And actually, we're outperforming in certain areas.
Great. Yeah. And I imagine too, it's the industry as a whole, you're doing one part of the battery, but also it would take a lot of retooling probably of the battery factories to make things work. Or would it? What would that take? Like, I know that they say that, if you want to go out and build a big factory, I guess it depends on what country you're in and what kind of regulations they have. But a lot of times you're
Right.
talking, 5 years or something before you have a nice, big, well working, streamlined battery factory.
You've touched on a really interesting point, Sean. There is a big, big push for domestic battery production and manufacturing.
Hooray for the
The
IRA.
Exactly. And not only that, but then, there's some significant tariffs or taxes on batteries from certain areas. So there's an economic reason behind it also. So yeah, I think we're going to see a significant amount of domestic battery manufacturing capability or capacity.
And so, like, if we have a battery factory that's already in the works or it's going to be done tomorrow, what would it take to retool that factory to use your silicon anode technology?
Not much. Our material, it's a slurry, and the slurry gets put onto the material. And so it wouldn't be that hard. I mean, to say that it's a drop in as an overused term, but it really is. It would not be difficult. And I should note that as we're going through this process, we have an outreach and a development where we're talking to potential partners. And these partners are battery manufacturers who are very well aware of our technology and our battery chemistry so that we're communicating with them so that when the time is right, we can deliver some of our material and they can start making some batteries with it.
And so you said that your technology is a slurry too. Maybe we could define what a slurry is because I think most people are not very into their slurry lingo right now.
In very high level terms, the slurry is where all the silicon and the graphite is mixed together. And that's applied to some sort of a binder material, and then it's put into the rest of the battery.
Would you consider cake frosting a slurry? Would that be a slurry?
Sure.
I
I'm
mean,
more of a
we're
frost.
talking about ice cream, so.
Sean, I'm more of a frosting guy than a cake guy. So yes.
Okay, good. Probably chocolate, I think too. Yeah. A little chocolate and lithium. They say lithium's good for you anyway, unlike those lead acid batteries.
Well, Sean, you're in the solar power. Lead acid batteries, have a great application. Weight doesn't matter
Uh-huh.
or not
Yeah.
as much.
Yeah. And so, yeah, they have a good application when it's cold. They can be charged and discharged a lot more when it's colder. And another thing is with the lead acid batteries, you can just trickle charge them, which is kind of neat. But it seems that lead acid batteries are kind of going out of style. I even know people in Alaska, they're using the lithium-ion batteries. Does this change any of those characteristics when you add your silicon anode technology, such as when it gets cold? Does it change how it works?
Not that much.
Hmm.
Not that much. That's still going to be a challenge for everyone.
Yeah, and still too, I think that there you can just have a little heating and cooling. I mean, pretty much on all cars, there's heating and cooling going on the batteries. And if you
Right.
don't have that, it's
Right.
not
That
going to
could be
work
a
too well.
significant drain.
Yeah, maybe that's why some of those
Right. Right.
Hoover
And
boards don't work so well. They like to get in the nude.
right. Right. Sean, what developments have you seen in the grid storage, energy storage arena?
I mean, I see it growing extremely fast. I see a lot of people focusing a lot on the smaller systems. They're talking about what they can put on their house, and that goes with solar too, because that's just what they see. But I think the bigger systems are growing really extremely fast. They're becoming extremely important. And I think that the future development that I'm really excited about are electric vehicles that can go bi-directional and support the grid. I imagine
Yeah.
that's going to be taken off really soon.
Yeah, I was at an automotive news conference years ago, and Mark Royce, the president of GM, mentioned that. The EV batteries, they hold a lot of energy.
Yeah, my car is sitting out right here next to me, 85 kilowatt hours, and my girlfriend's probably somewhere around 50 or 60. So we've got a lot of kilowatt hours here. It would be really
Yeah.
expensive and probably almost against the code to put that many batteries on the wall.
I do think that we're going to see some new uses and some new things coming out. There's some very creative and innovative people out there.
Another thing that I was just thinking about with your technology, let's say that you double the amount of energy a battery can store. So does that mean that you could double the amount of gigawatt hours that a battery factory could put out?
Gosh, I hadn't thought of it that way.
Like,
Yeah,
I
you
mean,
could,
it kind of makes sense that it would, just like you have a single battery there, it can hold twice as much energy. It's only so
right.
big, it's going through the assembly line, and you've got a factory that makes so many gigawatt hours. You should be able to double that and make that
Yeah,
factory, I guess, more than double cost effective, because you're going to have a similar overhead that you would have had in the first place. And so that should theoretically bring down the price of lithium ion batteries drastically, I would think,
yeah,
once they catch up with each other. I think right now,
yeah,
probably they can't make batteries fast enough. And if you could make batteries hold twice as much, then we would be catching up.
exactly. Yes. And also, we talk about the different applications. Certain applications need to have high power, right out of the box. For example, a drone. If they may need a lot of energy to get off the ground, but then once they get to cruising, then they can dial it back. So I can see situations where you may have two different types of batteries on board.
Mm-hmm.
And we've seen that development. We were at the battery show last month, and there are a couple places that are looking to do something similar to that.
Huh. Okay. Oh, two different types of batteries. So like one for power, one for energy, sort of like that.
Yeah.
The power would
Yeah.
help take off, like an accelerate, and then the energy gets you going long distances.
Exactly.
Huh, that's pretty
Exactly.
neat. And there's a lot of talk too, and I don't know if how true it is, but about electric airplanes doing the shorter hops, like we got San Francisco to Los Angeles or something like that. And this a technology that doubles how much you can hold in your batteries would pretty much make that work, I think.
Yeah. Exactly.
I wonder when somebody's going to drive all the way across the United States on one charge. That'd be a neat one. Uh,
That's a Charles Lindbergh kind of thing, isn't
uh-huh.
it?
Yeah, I imagine. I was going to think of how that might work. You get like a semi truck that's pulling a big battery. Probably, I would think could happen right now. I'm not sure, but and then it kind of reminds me of what they call the rocket equation and why they have all these different rocket stages. So maybe it would start off as a semi truck towing three big semi trailers. And then as the first one gets used up, they drop that. And then they have two trailers, drop it, one trailer, drop it. And then the last leg, they just have the front of the semi truck. Maybe I just gave somebody an idea and they could do a new Cannonball Run. Do you like Burt Reynolds?
Yeah, exactly. Yeah, that'd be funny.
Uh, so yeah, so this is all pretty neat stuff. And do you see any other parts of the battery industry that maybe even you're not involved with that you're excited about?
The other piece is the software, just being able to battery management systems that manage the output that goes into the computer system of the EVs or the drones or whatever. I think we're going to see some innovations there in this technology of the software.
And I always wonder about that software. So it's sort of like I have an electric vehicle, the warranty just expired. Are they going to do some kind of software update where it kills my battery? I mean, they could, I think theoretically. I mean, I don't think that they will because it's sort of unethical, but they might skew it a little bit more towards that side. And then I would need to buy a new car or a new battery. There's all these kind of unknown factors that we have out there. And then they figure out new, better ways of charging a battery. as time goes on. So, of course, they'll do software updates, but some software updates could make your battery not last as long in the long run, but maybe get you more miles in the short term or more energy in the short term. So, there's a lot of weird things that can happen out there if you had unethical people deciding how to do the software update.
That's true. Another area that's really hot right now is battery recycling. You know, your battery or your car is out of warranty, and at some point your battery is going to crap out on you. You know, how do you recover the good material out of the battery, and how do you handle some of the bad material?
Yeah, and if you're talking about silicon, I guess you don't have to worry too much about that because it's the second most abundant element in the Earth's crust. There's plenty of
Exactly. Yeah,
rocks around there. So,
exactly.
which is kind of neat to have some kind of material that's really important that is not rare at all. It's everywhere in the world, every country. It's on the moon, it's all over the place.
Right.
And then we have iron. So they talk a lot about the lithium iron batteries. And they say that the earth by weight is more iron than anything else. Because if you look at the core of the earth, it's a little hot down there. So it's kind of hard to get there and verify that. But, if you ask one of those astrophysicists, I'm sure that's what they'll tell you. And so, and lithium is not too rare. A lot of people think that, oh, we're going to run out of lithium and all that kind of stuff. But yeah, so recycling batteries, it's in recycling solar modules too, is kind of a big topic. And I guess too, part of recycling, I guess there's a couple of different things. One of them is we want to recycle things that are toxic, but with our lithium-ion batteries, it's not very toxic. I'm probably not going to eat them, but I probably wouldn't die if I did, not like with a lead acid battery. And so we have the toxicity thing, but then we also have to worry about, I guess people say, oh, we're going to fill up the landfills. That's one thing. But then the other thing is, oh, it's so hard to get more of the raw materials out of Earth. That's the other thing. And I guess too, if you figure out a way to use something that's totally easy to get, silicon, to make a battery do twice as much, store twice as much energy, then that means that we're going to have half as many batteries to recycle. We're going to have half as many batteries to throw away. And we're going to have to mine half as much stuff out of the earth. Well, except for silicon, but silicon is pretty easy to get. And I've never heard about anybody talking too much about silicon mining ruining the planet like they do with other things. I know like cobalt is the one thing that people are very concerned about. And then we have manganese, aluminum, not too hard to come by. But people that are working on this recycling, I have a friend that's working for a company that's doing some of the figuring out how to do recycling. You hear about them too, piling up lithium ion batteries in the desert, waiting for us to figure out how to recycle them or waiting for us to get enough where it's even worth it to recycle them. And then another thing too, they talk about is the second life batteries, where you take your electric vehicle and then after it's not working well enough to go the miles that you want it to have, then you replace it with a newer battery, and then you can take your electric vehicle battery, stick it in a rack, and it still might have over half of the energy after it's fully charged than it would have in the first place. And you can keep running that down and down for quite a while. And maybe you would get a whole lot more out of it than even for driving, because when you're driving, you want to go a long distance. So those are all pretty interesting things about electric vehicle batteries and things like that, and how we can use them for a lot longer period of time. In fact, in the National Electrical Code, there's Article 625, and that's for electric vehicle charging and discharging. And also we can look to Article 706 of the National Electrical Code. And one of the exceptions that we have in there when we combine those articles is that we can take our electric vehicles and use them to power our houses and not have to follow as many rules. It's almost like a loophole. It's kind of funny too, if you look at it, how much an electric vehicle battery costs with the car, like you include the price of the whole car. It's cheaper, I think, right now to go out there and buy an electric vehicle, so a four-wheeled battery per kilowatt hour, than it is to go buy a stationary battery that you put on your house per kilowatt hour, if you include all the extras like the installation costs and things like that.
That's fascinating.
Yeah.
And and
Yeah, and we
and,
get
and
that the IRA helps out a lot too.
right. And Sean, just to kind of, wind up the recycling talk, it's just good environmental responsibility to recycle, whether you're recycling batteries or aluminum cans. So it's really good to see that people are doing that.
Yep. Yeah, and I think we had a pretty good head start with lead acid batteries. I think they say that's the poster child for all recycling ever. And so you got this heavy lead that's, would cost you money to throw it away. And then they give them core charges if you go to the auto parts store. And so you get some money back for bringing it back, and you don't know where else to bring it anyway. And lead is super toxic. It might be the reason that the Roman Empire fell, because they liked how sweet it was in their wine. And so they kind of got a good head start for battery recycling for lead acid batteries. And so hopefully some of that transfers over to the lithium ion batteries. But then if something lasts forever, then we don't need to recycle it. And one of the things too about new technologies too is maybe it takes a while before people start trusting it, I guess. Like they don't know if it's going to last for 10 years because it's only been around for 5. Do you see people being nervous about that, or?
Oh, yeah, absolutely. I think there's a fair amount of hesitation in people buying EVs
Yeah.
just for that reason.
Yeah. Yeah. But let's see, my car battery is, I think it's 8 years old. And as far as I can tell, it's working as good as new. So that's a good thing. Get that out there. I know some people that have the same model car that I do, and their battery has gone bad, or, you read about it and Reddit and stuff like that. But maybe it's just a bad batch or something like that.
Yeah. And environmental conditions have a lot to do with that too.
Yeah. Yeah. So maybe if I lived out in the desert, my daughter lives out in Phoenix, and she's driving around whatever it was, 40 days in a row at 110 and over. That might put a load on her battery, or maybe a load on the cooling system. But yeah, if I look inside of her garage during those days, it was probably 100 degrees at night. So that might have been a little bit different than where I am in the San Francisco Bay Area, where it's just pretty good temperature here most of the year. It's more moderate, like cooler in the summer, hotter in the winter than even Ann Arbor.
Yeah. Yeah. We get some cold weather up here in Ann Arbor.
Uh-huh. So when can I go out and buy some of your batteries?
Well, we're still working on the anode piece, and we're not making batteries, but we will be partnering with some manufacturers. And I think, again, this goes back to the forward-looking statements. It's going to be soon. So
Uh-huh.
thank you.
Okay. Yeah, I got to keep trying to squeeze it out you soon. So I'll have to go look up and see what that means.
Yeah, exactly.
As a months, days, years, seconds, something in between there, probably.
Yeah.
All right. So let's see, is there anything else that you want to talk about or cover?
Oh, this has been very helpful. I enjoy our conversation. I've learned a few things today. And Sean, seriously, if you're ever out in Ann Arbor, please look us up. We'd love to show you around.
Yeah, for sure. I'll definitely do that next time I come out there and visit Brian Hayden from Heat Spring. I'll come and give you a call. And I also have some other friends in the area too. And that would be great. And let's tell people how they can find you and your company, or what kind of information you can give away about that.
Yeah, please. Again, we are publicly traded. Our ticker symbol is CRTG. Our website is the coretecgroup.com. We are also on Instagram. We have a YouTube channel. We just did a webinar a couple of weeks ago with some other battery companies, and we will be doing more webinars. We have fun with that. It's very much like this, Sean, where it's conversational and you just talk about certain parts of the industry. So, yeah, we appreciate you following us, and keep an eye on Endurion. We've got good things on the horizon.
Yeah, I enjoyed talking to you too. It was just kind of fun talking to you like a friend that I just met. So hopefully I'll see you some more. And then another thing too is I teach a lot of different classes on solar and energy storage. And if you wanted me to use some slides or anything, you can just send me some and I can put them out there to my students.
Fantastic. Thank you. I appreciate the offer.
Great. Thank you, Matt Kappers, and thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more about solar and storage and anodes, you can go to solar, SEAN, that's solarshawn.com.